Hello, welcome back to our channel. Today we are going to discuss about the magnetism and matter belongs to the crash course only. So this is also very easy chapter and it is very interesting also. When doing the problems, don't leave the chapter. Those who are choosing some chapters from the physics, don't leave this chapter. Anyway, come to our point. What is the magnet? If the body which is suspended freely, it comes to rest along the north and south direction of the earth. At the same time, it is attracting the magnetic materials like iron, cobalt, nickel, like that. So that is called the magnet. Then how to find out the length of the magnet? You can say that simply we can take one scale and we can measure it. See, but during the lab we can do like that. But what is the exact length of the magnet means we can take it. You know this. This is the magnet. It has two poles. One is the north pole, another one is the south pole. We can take this length is the 2L. Here 2L is the geometric length, but length of the magnet is, see, length of the magnet equals to 5 by 6 times of the geometric length. Here geometric length is how much? 2L. This is the geometric length, and with the help of this we can find out. One example also we are doing. If geometric length is 5 centimeters, then how to find out the length of the magnet? Length of the magnet equals to 5 by 6 times of this 5. Then 25 by 6. 4.1 centimeters. See how much difference is coming. So like that we can able to calculate the length of the magnet. Then what is the pole strength? Next one is the pole strength. Always it is represented by small f. Unit is the ampere meter. And dimensional formula is, this is the IL. See, what is the pole strength? It is the capacity to attract the magnetic materials at the ends of that magnet. That is called the pole strength. Then magnetic moment. Magnetic moment is represented by capital M. See, here we are taking one magnet. It has two poles. One is, that length is the 2L. It is the product of pole strength and length of the magnet is called the magnetic moment. And you remember that it is a vector, and the direction is from south to north. They are asking, chances are there, concept questions. What is the direction of that magnetic moment means you can say from south to north. Then unit is what for this? Unit is the ampere meter square, and dimensional formula is IL square. Then based on the magnetic moment, we are discussing many problems. First of all, look here. When you take one magnet, length we can take it L or 2L as you wish, you can take it. We cut the magnet X pieces along the length. Then what about the magnetic moment? So beginning what we are taking, M equals to L into M pole strength. But whenever you cut this one, how many number of pieces are there? X number of pieces. Here L is no change, but pole strength is decreased to X times. That's why magnetic moment, new magnetic moment is how much? M by X. It is decreased X times. Not only this one, if the magnet is cut perpendicular bisector or perpendicular to the length Y pieces, here what happens? M dash equals to, but here change in the length L by Y into pole strength is as usual. Anyway, magnetic moment also decreases to Y times. Suppose we are taking one magnet. This is cut into along the length X pieces and along the perpendicular to the length Y pieces. The new magnetic moment M dash equals to M by X into M into X into X by Y. Suppose if M equals to 20 ampere meter square and X equals to 5 and Y equals to 2. The new magnetic moment means M dash equals to 20 by 5 into 10 to 10. So magnetic moment is the ampere meter square. Like that we can calculate the magnetic moment when you cut this one. Suppose you are taking one semicircular, this one. Here this is the north pole and this is the south pole. Here this distance is 2r we are taking. In this case, what is the magnetic moment? As usual, pole strength into distance between the north and south pole means we are taking 2r. Then one more thing, suppose we are taking one magnet, this length is LR 2L, your wish you can take it. Now it is bent like a circle. Here what is the magnetic moment? M equals to 2L into M, 2L into M. But here in this case, when you are bending like that, how to find out? Suppose you are bending like semicircle here. You are bending like semicircle here. Radius of this one we are taking R. How to express this magnetic moment in terms of the length? Here semicircle means circumference is pi r equals to 2L. Then R equals to how much? 2L by pi. Then new magnetic moment M equals to, you know the distance between north and south pole is 2R. So pole strength into 2 into, instead of R what we are taking? 2L by pi. Sometimes you are taking only L, means here also you are getting the L only. In this case R equals to L by pi. So this is the L by pi, 2L by pi. So it depends on the situation, and based on that taking the that length of that one, we can able to find out the magnetic moment. Not only this one, there are many cases are there based on the magnetic moment. Suppose we are taking one magnet and bending at the center. See, this is actual magnet of magnetic moment is M. It is bent like that. Then what happens? This is M by 2. This is M by 2. You should consider exactly at theta. In this new magnetic moment, M dash equals to M sin theta by 2 based on the angle. Suppose M equals to 2 and theta equals to 60 degrees. Then what is the new magnetic moment? M dash equals to M into 60 by 2 is the 30, means M by 2. It becomes to half of that magnetic moment. Becomes to half of that moment. Then not only this one, look here. We are taking one magnet, it bent like an arc and it will subtended an angle here theta. In this case also new magnetic moment, you should remember that 2M sin theta by 2 divided by theta. Suppose initial magnetic moment is 4 and theta equals to, as usual I am taking 60 degrees. Then M dash equals to what we are taking? 2 into 4 into, this is 1 by 2 by theta. 60 degrees I am taking pi by 3 also. Then after simplification, 12 by pi ampere meter square. Like that we can calculate the magnetic momentum. Then we are going to discuss about, look here, one magnet is there, we can bend like U shape. Initial magnetic moment is the M. Now what happens? Each side, this is the M by 3, 3 parts, M by 3, M by 3, M by 3. Suppose this is the north, south pole, like that. So what is the direction of that magnetic moment? How to find out the resultant magnetic moment? See, this is south to north and this is south to north, like that you can take it. And here south to north. How to write this expression here? M dash equals to, see, x-axis minus M by 3 I cap. This is the minus M by 3 J cap plus M by 3 J cap. Why? One is acting upwards along the positive y-axis, another one is the negative y-axis. These two are cancelled. Resultant magnetic momentum is M by 3 I cap. If they are asking only magnitude, means simply we can take it the M by 3. Then not only this one, now we are going to discuss about different cases also. When we are bending like 5, there also with the help of the vector notations we can able to find out the magnetic moment. So till now we discussed about magnet, single magnet only. When you are bending like semicircle, arc at the center and cut, we know that resultant magnet after bending and all this. Now we are using the two magnets. See, this is the magnet of moment is M1 and this is the magnetic moment of M2. Here we are taking like poles intersect. Means here north pole, south pole. Here also north pole, south pole. See, direction is what? North to south to north. Here also south to north. So angle is how much? How to take this one? Here angle is the theta equals to what we are getting, resultant magnetic moment. This is 180 minus theta. Look here one more time, I am drawing this. See, suppose we are taking, this is the south pole, and here also south pole, south to north. Here also south to north. Angle is how much? Theta. Here resultant magnetic moment is how much? M equals to under root m1 square plus m2 square plus 2m1 m2 cos theta. Like that, one more case. Unlike poles, this is the south and north, and this is the north and south. Here direction is south to north, and here like this. So in this case, what is the resultant magnetic moment? M equals to, we are getting under root m1 square plus m2 square minus 2m1 m2 cos theta. Minus 2m1 m2 cos theta. Not only this one, based on the angle, we can go through the different cases. Here, one more thing we are going to discuss. Two magnets. This is the north pole, south pole, and this is also north pole, south pole. Here angle between these two, theta equals to 0 degrees. M equals to how much? M1 plus M2. Suppose this is the 30 and this is the 40, means we are getting resultant is the 70 ampere meter square. So look this one also. This is the north pole, south pole, and this is the south pole, north pole, M1 and M2. Here angle is how much? 180 degrees, south to north and south to north. Here M equals to M1 minus M2, like that we can take it. So this is completely belongs to magnetic moment. Then we are going to discuss about what is the magnetic field. The space around the magnet where it shows its effect. Suppose you are taking one magnet, this is the north pole and south pole. It modifies the space around it. This is called the magnetic field. Then magnetic field induction is nothing but intensity of magnetic field also we are calling. This is represented by B, and it is also vector quantity. See, B equals to force per unit pole strength. Here unit is the Tesla we are taking in SI system, and CGS system, this is the gas. One gas equals to 10 to the power of minus 4 Tesla. You must remember formula for this one. So this is about the magnetic field induction. Not only this one, this B equals to, we are writing mu naught by 4 pi m by d square also. And before that, we can take it Coulomb's law also between the two pole strength M1 and M2. The gap is the D. Here how much force of attraction or repulsion, we can observe that attraction means unlike force. So mu naught by 4 pi M1 M2 by d square. And remaining, you know that force is directly proportional to M1 M2. Force is inversely proportional to d square. And mu naught by 4 pi value how much? 10 to the power of minus 7. So this is about the magnetic, this mu naught is called the magnetic permeability. This magnetic force is inversely proportional to d square. You remember that mu naught by 4 pi value is 10 to the power of minus 7. So when you know this only, you can able to do the simplifications. Otherwise, you won't get the correct readings. Suppose we are taking, if M1 equals to 2 ampere meter, then M2 equals to 4 ampere meter, then D is the 4 meters. Then how to find out the force acting between that? This is the 10 to the power of minus 7 ampere meter. 2 into 4, 8 divided by distance square means 60. So answer is how much? 0.5 into 10 to the power of minus 7 newtons. Like that we can able to calculate the force. Not only this one, suppose if D1 equals to 4 meters, D2 equals to 8 meters, and the pole strengths are the constant, means how can we find out the ratio of forces? This is simply, you can take it D2 by D1 whole square, because both are inversely proportional to each other. So our answer is how much? 4:1. And you remember that this mu naught is the permeability of the free space. When you are going to the medium, what happens? That is the permeability of the medium. That is the property of the matter affecting in the case of magnetic and magnetism and all these cases. And mu equals to mu naught into mu r. Mu r is called the relative permeability. Same like electric charges and fields. Here also it is Coulomb's law in magnetism, and this is like intensity, magnetic induction mu naught by 4 pi m by d square, and one more is the force per unit pole strength, and there we are taking force per unit positive test charge we are taking, that only difference. Now we are going to discuss about what is the magnetic induction in the case of magnetic dipole, magnetic induction of the magnetic dipole on axial line, equatorial line. That formula simply you have to remember this one, B equals to mu naught by 4 pi m by d cube into under root 1 plus 3 cos square theta. 1 plus 3 cos square theta. See, for axial line theta equals to 0 degrees. So magnetic induction of axial line is how much? Mu naught by 4 pi 2 m by d cube. Why? This is 3 plus 1 4, under root 4 is the 2. Like that, equatorial line theta equals to 90 degrees. You are getting simply mu naught by 4 pi m by d cube. But the thing is, these two are belongs to short magnet. This is belongs to short magnet, axial and equatorial line. Suppose it is 60 degrees instead of theta, we have to put that 60 degrees, and we can simplify and find out the magnetic induction. See, for long magnet, axial line is mu naught by 4 pi 2 m d by d square minus L square whole square. L is the length of the magnet, d is the distance of the center to that particular point on the axial line. Then BE equals to mu naught by 4 pi 2 m by d square plus L square whole to the power of 3 by 2. When we are taking the ratio of axial to equatorial line, we are getting 2:1. We are getting 2:1. So then we are going to discuss about couple acting on magnetic field. On the magnet, we are placing in uniform magnetic field. Tau equals to mb sin theta. Here you know that tau maximum is when theta is 90 degrees, tau minimum equals to 0 when theta equals to 0 degrees. Like that, work done, here also work done minus mb cos theta. When we are doing the integration of this, we are getting this expression. It is stored as a potential energy also, mb cos theta. When we are taking the limitations, we are getting cos theta 1 minus cos theta 2. This is about the energy on the magnet placed in the uniform magnetic field, and this is in the case of turning effect of the force on the magnet placed in the uniform magnetic field. Then we are going to discuss about what is the magnetic lines of force. It is an imaginary path of the unit north pole. Unit north pole means we are taking the compass. Already we have done in lab also how we should draw the magnetic lines of force. So then we are going to discuss about here also null point. Null point in the case of force and null point in the case of magnetic induction. Common formula, x equals to d by under root m2 by m1 plus or minus 1. You can take plus for like poles, and minus is for unlike poles. Minus is for unlike poles. And here time period also we can find out. T equals to 2 pi into under root I by mbh. mbh is the horizontal component of Earth's magnetic field. M is the magnetic moment, and I is the moment of inertia of that particular magnet. So from this what we are writing, this time period is directly proportional to I when M and BH are constant, and this is inversely proportional to magnetic moment. When you know the time period, you can able to find out the frequency also. Then we are going to discuss about elements of the Earth's magnetic field. There are 3 elements of the Earth's magnetic field. What are those? First one is the magnetic declination. Second one is the magnetic inclination or dip also we are calling. Third one is the horizontal component of the Earth's magnetic field. See previous, what is the magnetic declination? What is the magnetic declination? See, this is the Earth. They were thinking magnetic meridian is coincides with the geographic meridian, but later they observed that small difference is their magnetic meridian and geographic meridian. So this angle, the angle between these two is called the magnetic declination. It is represented by theta. Then magnetic dip or inclination means, see, this is the magnetic induction. When it is resolved into two components, this is horizontal and this is the vertical component. So the angle between horizontal component of Earth's magnetic field, this magnetic induction is called the magnetic dip. Here B equals to under root BH square plus BV square, also we can write it. At the same time, tangent lies the B equals to BH tan theta. This is about this one. The next one is the, what is the intensity of magnetization? Intensity of magnetization, I equals to two formulas are there: magnetic moment per unit volume or magnetic pole strength per unit area. Any formula you can take it. Then magnetic strength field or intensity of magnetizing strength, H equals to strength of that one, B equals to, we can take it, mu naught into H. Then H equals to B by mu naught for free space and H equals to B by mu for medium. When you know this, we can find out that magnetic susceptibility psi equals to I by H. This is the formula for that. Then these are the magnetism and matter. Almost I have covered all formulas also. Then last one is like what is the coercivity and what is the resistivity and all is there. Just a concept you can follow from that one. So this is about the, and one more formula I want to share with you, that is B equals to, we can write it mu naught into I plus H, also we are writing, and we are taking B equals to mu into H, mu naught into this one. So these are the relations. When you know one, automatically you can find out remaining things also. So this is very small, this is small, somewhat moderate chapter. It is easy only, better you have to by heart the formulas or logically you should remember. So but it is somewhat interesting only comparing with other chapter. So thank you everyone, please subscribe my channel.